Testing. Mic check. Testing. Mic check. Yeah, so we're just gonna solve this. I'm gonna start soon. So first let's try sketching the graph of y equals to x plus 3a without the absolute value. So it'll look like something like this. X plus 3a. So let's try sketch graph of y equals to x plus 3a. A is positive, so it's above the x-axis. So don't forget to draw the axis. Then you'll have something like, wait, something like this, I believe. But when it crosses the x-axis on the negative side, it should be reflected. So let's try to find the x-intercept. So for this one, you just have to have it's going to be either positive or negative, as in this can be two cases, which is either this sorry, positive or negative. And then for both cases, we solve the inequality. So let's take, for example, this one. Take apart the brackets, open up the brackets, isolate the x's and the a's. So we have 3x. A minus 3a is negative 2a. X is greater than. And for this one, we have negative x. X plus 2x is negative x plus 2x is x. And a plus 3a is 4a. So now we have two different values of a for x. And when you try to draw a line, right? So we have a line. So let's say we have a line here. And one of them says that x is greater than 4a. So it says here x is greater than 4a. And then the other one says that x is greater than negative 2 over 3a. So it goes there. So we can see that our conclusion is that x is greater than this. So hence x is greater than negative 2 over 3a. Okay, we're done for question 1. Now let's try marking our answers. Sorry, my bad. Let's try that again. It's kind of wonky when I'm using my pen. So yeah, that's the answer right there, as you can see. Now let's move on to question 2. Solve the equation 3 times 2 to the power of x plus 1 is equals to 4 times 3 to the power of 2x minus 3, and then give your answer to 3 significant figures. So 3 as f. So let's take a look. We have 3 2x plus 1 equals to 4 3 2x minus 3. And then the first thing we can do is this 4, we can change it up to 2 to the power of 2. And then, oops. And then what I do next is let me try to think. So I would try to isolate the bases, as in this one is the base here is 2, so we'll isolate them. We'll have 2 and 2 together, and then 3 here, 2x minus 3 over 3. 3 to the power of 1. This is 3 to the power of 1. And remember the power rules, wherein if you divide uh, a number, you divide two numbers of the same base, it means that for the base, it's literally, the power is subtracted. So for example, this one is divided by 2 to the power of 2, so it's minus 2. This is 3, 2x minus 3 minus 1. Now, we'll simplify that. X minus 1 minus 4. So what else can we do now? I will try, let's try to put ln or any logarithm in both these numbers. So let's put ln in both of them. Then using the logarithm rules, can put the power to the front. So we'll have x minus 1 ln 2 is equals to 2x minus 4 ln 3. You can see that now, right? So x, we just expand the brackets, put these values in. And for the terms that have variables, we'll just put them on one side, while the others, we put them on the other side. So let's have ln x2 minus ln 2 is equals to 2x ln 3 minus 4 ln 3. And then we have x ln 2 minus 2x ln 3 equals to negative 4 ln 3 plus ln 2. So we can factorize this part. So we have x times ln 2 minus 2 ln 3 is equals to 4 ln 3 plus ln 2. And then we can divide the whole thing by this term here. So we'll have x is equals to negative 4 ln 3 plus ln 2 divided by ln 2 minus 2 ln 3. Now, if in the question they stated that they want, if it's stated in the question that we want an exact value, we are able to combine the ones on the top and the ones on the bottom by using the rules. For example, let's say here we have ln 3 plus ln 2, 84. It'll be ln 2 minus ln 3 to the power of 4 equals to ln 2 over 3 to the power of 4. But in this case, it's not needed. So we'll just put these values, we'll plug in these values in a calculator. So now I'm putting in the values. We have negative 4 ln 3 plus ln 2, and then divided by ln 2 minus 2 ln 3. Let's hope I don't make any mistakes. So it's stated in the question here, we need to have it correct to 3 significant figures. And from my calculator, we have x is equals to 2.46085. And then we round that off to 3 significant figures. So now let's, do we have anything else? Now let's verify our answers. So yeah, that's the answer. We're pretty much correct. Now, for this question, it's about complex numbers. Now, let's see, the shaded region in the Argand diagram, bounded by a line and a circle, represents the complex numbers z satisfying this. Real number of z is less than or equals to 2. So it's less than or equals to 2. And then we have z with from this position 3 plus I, we have a radius of less than 2. So it means that this indicates the radius of the circle. So it's less than 2. So when we have both of these conditions, we shade the shaded area is the intersection of these two conditions. Now let's take a look at the first sub-question. Point P shown on the diagram is one of the points of intersection. Find the complex number represented by the point P. So firstly, we can see that this is a line. Z is equals to 2. And then the other one is a line z minus 3 plus 1 is equals to 2. And we want these to be, we want to find the intersection. So this is equals to this. And since z equals to 2 and the next equation is also equals to 2, so we have z is equals to z minus 3 plus I. Almost put it as 1. So now if you see this modulus means absolute value, it means it'll go positive or negative depending on the value inside. So we'll have two cases. But when you take a look at this diagram, we can see that point P is in a lower part, which means the y coordinate or imaginary coordinate of P is less than the imaginary coordinate of the other root or intersection. So once we find our value of once we find our z, we want to make sure that for the form x plus yi or iy, we want the y of p, it has to be less than the y of the other intersection point, which is, let's say, q. So let's just label this here as q. So this is our condition. The y of p is less than y of q. Now, let's open up our modulus. And for the first case, let's just have it as positive, z minus 3 plus I. And so z is equals to z minus 3 minus I. Oh no. I'll be quite frank here. It appears I might be stuck. Complex numbers. I'm in a bit of a situation. Let's try to figure this out together. Now for our other case, right? We also have z is equals to z is equals to negative z minus 3 plus I plus 3 plus I. So 2z is equals to 3 plus I. but in this case, it shouldn't be possible. We know that the real value of z should be 2. It cannot be anything else. I'm still trying to figure this out. Oh, so yeah, it appears I made a mistake here in having our first equation as z is equals to 2, but actually it's only the real value of z is equals to 2. So yeah, my bad. So let's do that again and say let z is equals to x plus iy, or I'm more comfortable with using yi, but let's just use iy. And then we have the condition real value of z is equals to 2. So it's z is equals to 2 plus iy. And then here we have 2 plus iy minus 3 plus I is equals to 2. Okay, we can see that here now. And then we can do simultaneous equation to have 2 is equals to z minus iy. So putting it into this equation, we have 2 plus iy minus 3 plus I. Wait, I don't... Let me think about this for a second. I don't think I should be substituting the value of z here. Let's just leave it at z. And this is equals to z minus iy. Right, I think we're getting somewhere. Now, since this is a modulus, now like the previous case, we'll just divide them into two cases, positive and negative bracket. Now for our first case, we have positive z minus 3 plus I, is it? Is equals to z minus iy. Solving this, we have z minus z. Ooh, might have a problem here. Minus 3 minus I plus iy is equals to 0. So we have negative 3 minus plus y minus 1i is equals to 0. I don't think that should be the case. I might have made a mistake somewhere, but we're quite wasting our time right now. So I'm just going to skip this part. All right, let's proceed to question 4. So I apologize for that. We'll take a look at that later. I'm still quite struggling with, with complex numbers and imaginary. So I'll have to study that before my paper tomorrow. A trial paper. All right, let's try find the exact value of this integration. Do we have any questions after that? No? So just question 4. So the first thing we're going to do is that this is inverse tangent. So I'm going to refer at our MF19. So taking a look at our MF19, if we have anything related to inverse of tan, inverse of tangent. Now it doesn't look like we have anything related to inverse. So I believe we will have to figure that out ourselves. Let's take a look. This is x and inverse of tangent here. So it might, I believe, it's hinting to a integration by parts using UV, but let's try to think of it. X inverse of tangent. Inverse of tangent. Oh, so yeah, I found this here using this part here from our MF19. I just missed that out. So we're gonna use this. So it says here this is, if this is our, yeah, if we integrate this, no, sorry, my bad. No, I don't think that's going to work. I'm quite clueless at the moment. I'm gonna have to think. Try to think. So unfortunately, I might have to refer to Google for this one. Let's skip that one a bit. Let's just skip that one and just try to do this one first. We'll go back to the questions where we're stuck by later and then refer to Google. So fx is equals to this. fx is a GXR polynomials, and we want to show that x minus a is a factor of f prime x. Now we have this function. Firstly, let's find our first derivative of fx. So this is using this. So u is equals to x minus a squared. U prime is equal to 2 x minus a times 1, but let's just leave it at that. and then v is gx, and v prime is g prime x. So we have f prime x is equals to uv prime plus vu prime. That's equal to x minus a squared. V prime is g prime x plus 2x minus a gx. And then x minus a is equals to 0, x is equals to a, f prime a is equals to a minus a squared g prime x plus 2a minus a gx. So we have a minus a 0, 0 times g prime plus 2 times 0. So it's just 0 plus 0 is equals to 0. F prime a is equals to 0. Shown. Let's verify our answer for question 5. I hope you can see that. I don't think you can see that. Well, maybe we should expand our screen a little bit. So next, it's given that, oops. Yeah, I'm going to have to. So given that x minus 3 squared is a factor of this. So the second question, the second sub question is usually a hint to the first one. So this is a factor of this. P and Q are constants, and find the values of P and Q. Now, when you take a look at this is a cubic equation, and this is a quadratic equation. So let's let this is a function f. We'll define this as the function of x, where this is a cubic function, and then there's a factor, a quadratic factor, and then what's left should be a linear function. So let's just put gx such that gx is linear, or y mx plus c. So I don't think you should, this isn't compulsory to write, but I'm just writing this from my understanding. So we have a quadratic times a linear equation. It'll form a cubic equation, obviously. So now find the values of P and Q. So let's see now. Previously we've proven that for x minus a, right? For this one, x minus a squared gx. We know that x minus a is a factor of f prime. So we're gonna try to find f prime. In this case, f prime is 6x squared minus 4 times 2, 8x plus p. And you can see that we've eliminated our q, so it's easier to find the value of p. And then for x minus a squared, we can see that a is a root. So in this case, our a is 3. This can be seen like our A from the previous question. So we'll just plug in A. Sorry, my bad. We'll plug in 3, and it should be a root. Why did I put 2 over there? See, that's where I can make mistakes. Plus P is equals to 0. Now we can easily solve for P now. I'm going to plug in our values into to my calculator. We have P is equals to -30. Is that correct? Really hope that's correct. So now we have our f of x. Writing back f of x. Function f is equals to this minus 30x plus q. Now let's see, what else can we do to find the value of q? Now, I'll just blindly attempt a division. Yes. We'll try this method. So x minus 3 squared is equals to x squared minus 6x plus 9. And then we're going to divide this. We have minus 30x plus q here. So for the first one is obviously 2x. I should put that in the front. So we'll have 2x cubed minus 12x squared plus 18x. So we'll have left over, this is minus. I don't think we should write that. But we'll have here 8. Is that 8? 8x squared minus 48x plus q. So we just have to match the value, the coefficient of x squared, our largest term. So 1x squared, we want to turn into 8x squared. So we just write 8. Then we'll have 8x squared, and minus 6 times 8 is 32x. Wait, no, 6 times 8 is 48x, my bad. Then 9 times 8 is 72. And this should result in 0. So we know that from here we can see that q minus 72 equals to 0. Hence, q is equals to 72. So our conclusion is that p is equals to -30. Q is equals to 72. And is that correct? Let's move our conclusion a bit to the left here so we can paste our answer here. Yep, so it's -30 and q 72. All right, moving on to question 6a. Sketching a graph, show that this equation So let's start with our axis. We have x and y. So we want to show that this has exactly one root. Now, when we want to show that something, when this y is equals to this and y is equals to this, when we have two different equations that has only one roots, so it'll mean that whatever we draw, it'll have only one intersection. So we'll want to draw the graph of cot 2x and then draw the graph of 2 sine 2x minus 1. I think an easy approach would be to first draw this one, second one, and then make sure to that our range of values, our domain, is inside the given condition. So we have 2 sine 2x minus 1 within this. So sine, let's have 2 sine 2 0 minus 1. So this sine 0 is 0, 2 times 0 is 0, minus 1. So we will start at negative 1. Let me put negative 1 here. And then it'll follow a sine graph. And looking at here, we have our amplitude is 2. So the maximum should be 1, minimum should be negative 3. It'll look like something like this. But before we finish drawing, let's see what point 2x is actually is. So 2x until half of pi, x is equals to half of pi, which means our final value is sine pi. Pi is 90 degrees. So you can kind of sketch a little graph here showing the original sine graph, and this is 90. So we have here pi, which means for this case, we'll have the graph go up until, up until its halfway point. Let's make that larger so it's easier to see. Yep. And the maximum displacement should be 1. Okay, now that's easy. Then we have cot 2x. So how do we draw the graph of cotangent? Cotangent is just 1 over tangent. Now when you draw the graph of tangent, we'll have something like this. And then you want a 1 over that. So if you 1 over 0 would be infinity. Then this point here, this point is half of pi. But we go until 90 cot 2 half of pi. So we go up until cot pi. So we just want to draw until the midpoint of a full graph. So it's something like this. So it goes from y equals to 0, and then halfway is y equals to infinity and negative infinity, the asymptote, and then finally end in y equals to 0. So that will look something like this, right? Now we'll try to draw that here. And then we can see the intersection point here. Just circle that intersection point. And so we have exactly one root now. Let's move on. Now show by calculation that the root is in the interval 0.4 to 0.6. Show by calculation. So I'm going to guess that this is, or is this simultaneous equation? So cot 2x. This is 1 over 10. And we'll time the whole thing by tangent, so it's 2 sine. Now, what can I do in this case? Oh, I forgot to yeah. So tangent is sine over cos. That's probably 1 sine squared 2x. What else can we do? I don't think it should be this complex. Try to think. How do I show by calculation that the root is in the interval? In this case, we should isolate the x, make x the subject. Let's skip this one also. It's quite hard. I probably need more revision in this kind of questions. But let's just move on. So question C, use the iterative formula to calculate root correct two decimal places. So I don't know if I should rewrite this, but I think we can use this. Can use this table. So for this case, we'll first write in our calculator, like put the whole thing. We're going to use radian, make sure to use radian. So for our first yeah, so we'll start initially, we will start with the root should be somewhere between this. So let's just start with the midpoint. So let's have our midpoint 0.5. In our first iteration, we will have 0.4858. And the next iteration will have 0.4967 to 0.4883, then to 4947 to 4898. Is it supposed to go this long? But let's just continue. Our sixth iteration, not 0.4935, 0.4906, 4929, 4911, 4925, 4915. Oh, to calculate the root corrected two decimal places. So we should have ended. This one would have been. Wait, this should have been 49. This is 50. This is 49, 49. So this wasn't needed. So 0, 0, 0. So this is 0.5000, 0.4, wait, 50, the 49, 50, 49, 49. So this was not needed. Hence, the root x is equals to 0.49. Taking a look at the answer, 6C, So yeah, we did get that mark, fortunately. Right, we move on to calculus. This part is a little bit more exciting compared to, you know, those function questions. This, this is a differential equation, is it? Now, first thing we have to move the x to the top, then move the variables to where their respective terms are. I mean, like if the dy is at the left side, then move all the terms with y to the left side and x to the right side. Wait. Oh, sorry. This is my bad. We want to go from here to here, so we're gonna do implicit differentiation. I believe that's what it's called. It's where you dy dx. We differentiate each term individually. So we'll just d dx 2y3 minus d dx 3x squared y is d dx x cubed equals to d dx 16. So for the first one, this is a function, right? So it's going to be so let's recall the rule for y is equals to x or something. D dx dy over dx should be 1. So what does that tell us? Does that mean we should leave that? Wait, no, 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 no. D over dx of y squared. It should be 3y squared, right? Is it? Should it? Oh, yeah, yeah, yeah. So we're differentiating it. It should look like this, I think. So it'll be 6y squared dy over dx minus wait, I'm not thinking correctly. Should it be yeah, I think that should be correct. And then minus 3x squared is equals to 0. Then we will isolate the dy dx's. Maybe rearrange this a little cleaner, having the higher degrees at the left side. And we can factorize 2. No, factorize 3. So we'll have dy over dx 2y squared minus x squared is equals to x squared plus 3 2xy. And finally, dy over dx is equals to x squared plus 2xy, divided by 2y squared minus x squared. So shown. Taking a look at the answer, yep. So hence find the coordinates of the points on the curve at which the normal is parallel to the y-axis. So visualizing this, when it says normal is parallel to the y-axis, means that the gradient is infinity, or whatever we have, something divided by something, this this what do you call it? The determinant, is it? No, the denominator should be equals to 0. So let's try to do that. And for your, in case you forgot, m or gradient is just dy dx. dy, the first derivative is the what do you call it? The first derivative is the gradient function. So looking at our working, we have dy dx equals to x squared plus 2xy over 2y squared plus x squared. Is it? X squared plus 2xy, 2y squared plus x squared. I have to double, triple, quadruple check here. Is it plus or minus? It's minus. Okay, okay, okay. So almost I almost got that wrong. So this one here should be a minus. When we say the normal, this is a gradient of the normal. So this is equals to the gradient. And then the gradient of the normal, it should be perpendicular. So let's say we have a gradient. The normal line should be perpendicular. And there's a formula that relates these equations, these gradients. The normal times the gradient is equal to -1. So normal is just -1 over m. So it's just -1 over the whole thing. The whole thing. Yep. So when it's over the whole thing, it will be -1. And the whole thing is flipped. And then we'll have okay, so this is the gradient of normal. And then it's parallel to the y-axis, which means this here is equals to 0. So x squared plus 2xy equals to 0. x plus 2y equals to 0. And then find the coordinates of the points on the curve at which the normal is parallel. So our first situation is that x is equals to 0. We have x plus 2y equals to 0. So how do I find y now? Shall we put it back on our initial equation? I think that should be possible, I think. Is it? No, I'm a little bit stuck right now for this case. I mean, an easy way would be to plug in x is equals to 0. So we just have 2y cubed is equals to 16, y cubed is equals to 8, y is equals to 2, positive 2. But then we have another coordinate. So we're going to have to find that. Can we plug in this? Oh, we do. So let's um let's copy. Let's just copy this equation. So first it's 2y cubed minus 3 0 squared y minus 16, and then we have y is equals to 2. And then here we have x is equals to negative 2y. 2y cubed minus 3. Wait a second. 3 negative 2y squared y minus negative 2y cubed is equals to 16. And we'll have 2y cubed. This is 4, so negative 12 y squared y cubed. And then plus 8y cubed is equals to 16. 2 plus 8 is 10 minus 12 is 2y cubed. It's the same 2y cubed, right? Is it? No, it's negative 2y cubed is equals to 16. And then y cubed is equals to negative 8. Y is negative 2. So we have the coordinates at x is equals to 0, y equals to 2. And then for this one, x is equals to negative 2, negative 2 equals to positive 4. X equals to 4, y equals to negative 2. Looking at our solution, it is correct, though I'm skeptical on our method. No, it is the correct method. Moving on, we have question 8. Prove the identity sine of 4x is equivalent to 4 sine x of whatever this is. So an easy method would be to take the more complicated looking side and then simplify it. And then we can see that it goes from this angle and then it'll double angle and it'll double again into sine 4x. So just writing this, it's 4 sine x. You can factorize the x, right? So 2 cos squared x minus 1 looks a little bit familiar if you go and refer to your MF19. I can see that one of the what do you call it? One of the equations here we can find is that 2 cos squared a minus 1 is also equivalent to cosine 2a, or 1 minus 2 sine squared a. So I think, oh yeah, I think we should definitely turn this into 4 sine x cos x, and then this will be is going to the front, and then this will turn into cos 2x. And then using this, it's also equivalent to 2 sine x cos 2x. Okay, this one is actually quite easy. This is equals to 2. And then 2 sine x cos x is equals to sine 2x. And then this is just 2 sine x cos x, but it's doubled again. So we have sine 4x. And proven, shown. So looking at our, yep, it is definitely that easy. Oh, but this one is for this method, for the method shown in the marking scheme. I'm using an alternate method, but it is just the same. So moving on to question 8b. All right, now this question, it kind of looks a little hard because it's integration of trigonometric equations. But first of all, let's just substitute that into the equation that we have previously, which is 4 sine x to cos x minus cos x. And then what? If I'm gonna expand this, we will have for sine x cos qx times 2 cos qx minus cos x. Then we'll have 4 sine, sorry, we will have 8 sine x cos 6x minus 4 sine x cos 4x dx. So try to recall what happens if we, let's try to take a look what happens if we go from cos 7x, so cos 7x, and then we differentiate it, right? Then we'll have a 7 cos 6x, and then a negative sine x. So we'll have a negative 7 sine x cos 6x. But this is an 8, which means we're going to have to plus that later. What can we do now? Would it have been better to integrate it by parts? Let's just take a look now. -7, and then we're gonna have to plus by 11. So we should be getting 11 somewhere. So -7 sine x cos 6x plus 11. Wait, should it be 11? No, 7, 8, it's 15 sine x cos 6x, which means we should be integrating this one. And it's, oh, this isn't good. Might have to find another method, a different approach. Can we go down? Down, down, down to 10. To 11. So it goes until that part. But it's quite hard if you ask me. So I think I'll have to skip that one because we're running out of time. Now let's move on to question 9. Expressing function x in partial fractions. Express fx in partial fractions. What can I do? What can I do? I'm starting to forget how it works. So like it should be a over something plus b over something plus c over something. But what about this? Firstly, I'm going to expand the denominator. X squared plus 3ax plus 2ax plus 236a squared. You can see the difference here, right? One is it's not enough. Wait. So this turns into this. We want to make it equal, right? But it's missing one ax. So we just add one ax and then remove it again. So then we'll have this. And then we'll have 1 minus ax over x squared plus 5ax plus 6a squared. Right. Then what can we do? What can we do now? Oh yeah, it's just ax. Now we're gonna do partial fraction for this one. So it's ax over is equals to a over x plus 2a. Right. Then we have ax is equals to a times x plus 3a and plus b times x plus 2a. And then we wanna um put x such that a will just one of the roots, or yeah, x plus 3a, we want it to be 0. So x should be negative 3. X equals to negative 3a. So we have a negative 3a is to a negative 3a plus 3a is 0 plus b negative 3a plus 2a is negative a. So negative 3a squared is equals to b negative a. Cut that. So we have negative 3a equals to b negative b. Cut that off. And b is equals to 3a. And then for our next case, x is equals to negative 2a. So when and then we'll have a negative 2a equals to a negative 2a plus 3a is a plus b 0. And we'll have capital A is equals to negative 2a. So then we have ax over whatever is below that is equals to negative 2a over x plus 3a, and then plus negative 3a over x plus 3a. So this is 2. And then substitute that back into the original equation. So we have fx is equals to 1 minus this thing. So we have, since it's minus, this is positive, and this is positive. So instead, it'll be plus. So it's plus 2a over x plus 2a, and plus 3a over x plus 3a. Okay, let's take a look. Excuse me. If we have same, the same. Wait, so apparently I got this part wrong. Yeah, B is 3a, whilst C is, oh my goodness, I might have done a mistake somewhere. B is equals to 3a. Why is it negative? Have I done something wrong? Oh wait, no, I didn't do anything wrong. So B is positive 3a, So then if it's negative, then it turns into negative 3a. Let's hope I'm right. Yep, doing slight adjustments. We did get the correct answer. Right, congratulations to me. Hence, find the exact value of. Damn, this one is quite difficult for me. My my brain is slowly shutting down, so I have to finish this quickly. Let me take a 5-minute break. I'm gonna take 5. Right, I'm back. I don't know if that was 5 minutes, but just finished brushing my teeth and I feel a little bit fresher. So fresher. So let's continue our battle. We're gonna go ahead and finish until go ahead and do this until I reach the 2 hour mark, in which we will go through the paper with the marking scheme to check whatever I've been missing. All right, let's go ahead and continue to find the exact value of f of x, fx dx. Give your answer in that form. So we'll just rewrite that in this form. Is that correct? Then dx. And we will integrate that one by one. So it's gonna be x, and it's gonna be, so let's do a little working here. Let's say we have x plus 2a, and then we differentiate it. Wait, sorry, my bad. Let's say we have ln of x plus 2a, and then we differentiate that. We will have 1 over x plus 2a, and then times 1, right? But in this case, we have 2a. So I believe that'll be 2a ln x plus 2a. And then if we differentiate that, we'll have 2a 1 over x plus 2a. So we just reverse that, we'll have 2a ln x plus 2a. And then do the same for this one. And then we have our limits a to negative a. So we're going to have to substitute that in. This minus this is equals to this minus this minus this then we'll have a plus 2a ln 3a minus 3a ln 4a, then plus a minus 2a ln a plus 3a ln 2a. So, that's really confusing to see. 4a, 3a, a, and 2a. Then we're gonna have to simplify. We'll have 2a's and then we have, wait, let's see the shape. It's the form of, okay, p plus non-q. So it's just a, then 1, okay, let's put this here, a 1 plus 2 ln 3a minus 3 ln 4a plus 1 minus 2 ln a plus 3 ln 2a. We have a2 plus Let's see, we have a huge lawn, and our first term is 3a. This for each of these lawn terms, right? We just rewrite them as lawn 3a squared, and then for this one is for a cubed, and then for the same goes for the others. So we have this one large lawn logarithm, and we just rewrite them 3a squared. So if it's minus, then we divide it. So it's 4a squared. Then we have a squared. Oh, this is not squared, it's a cube. And then final one to a squared. And then we're gonna have to work that out to simplify. So 3 squared is 8. Oh, sorry. It's an a 9a squared times 4a squared divided by 4 to the power of 3. We will have 64 a cubed. Oh, so this is a cube, right? So it should have been an 8 and a cube and an a squared. So cut that out. 8 to and this one 8. So it's a 9 over 8. So it's a 9 over 8. We'll have and yep. So did we get the answer? Matter of fact, yes, we did. Okay, moving on. Is this the last question? Should be 11 question total. So we're in the second last question. Right. So we have a tank, cube size 50, maximum height should be 50. At time t seconds, the depth of the water h is h, or whatever that is. And water is poured into the tank at a rate of, so we have dv over dt is equal to positive 5,000. We have volume is equals to h, wait, so volume is equals to, um, volume of the water is just 50 times 50 times height, or 50 squared is 2500 h, and then dv over dh is just 2500, right? Okay, I have might have missed something, but that looks about right. Oh, so water pours out of the tank through a hole in the bottom at a rate proportional to h squared. So there's also dv over dt is equals to negative h squared. So then we have dv over dt is equals to 5,000 minus h squared. And then we want to find dh over dt is equals to dv over dt times dh over dv. Dh over dv, from this up here, we have 1 over 2, 5,000. 500. So that should be 5,000 minus h squared over 500. But water pours out It says here it's proportional, but that, oh, okay, okay. So it's proportional, which means there is a k value here, and it says here when h is equals to 20, dh dt equals to positive 0.4. So we have 5,000 minus k 20 squared over 500 is equals to 0.4, and then we're gonna obtain the value of k. So bear with me on this one. 5,000 minus k 20 squared over 500 is equals to 0.4. Solving for k, we have k equals to 10, and then we can substitute that back. So dh over dt is 5,000 minus 10 8 squared over 500, and then that's equal to 500 minus 8 squared over 250. So given that h is equals to 0, time is equals to 0, find the time taken for depth. H is equals to 20, times equals to what? Looking at our initial question. Looking at our initial, so we want such that when we plot a graph, right, we have something, h and t. No, 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 no. Should it be the case? Try to think. I will guess. I'm gonna take a guess, and maybe we have to find from 0 to t dh over dt, and then it's equals to 20. So let's try that. So from 0 to t, right, we have 500 over 250 is 2 minus 8 squared over 250 dt. Is this correct? I don't think I'm finding the correct thing here. So No, you know what? Let's just try to solve that. This shouldn't be the case though. I think we're going at the wrong direction right now. We're supposed to find dH over dt in terms of time, you know. To t. I feel like I'm missing something. Okay, let's you know what? Let's just proceed. So we have 2t minus h when time is equal to t squared 250 t minus 2 times 0 is 0. Just put lah. So 0 is equal to 20. And then we'll have 2t minus when time is equal to t, h is 20, right? And then it's squared and it's 250. As t is equal to 20. So this is it. So 2 minus 400 over, sorry, that, yep. So 400 over 250 is, 400 over 250 is 8 over 5. So 2 minus 8 over 5. T is equals to 20. Time is equals to 8 over 5. 50 seconds. Yeah, I think that looks correct. All right. Off to our last question. Ooh, unfortunately, we didn't get the right answer for this one. Let's just copy. Yep, so did a little bit of a bad thing over there, but it should be fine. Let's continue to the next question. What? I'll just attempt this last one before we move on to marking with our red pen, and then do our the and do whatever we have left. So find the vectors MB, MC. M is a midpoint, so we're gonna have to find so MB, right, is half of AB. Right. So it's half of OA minus OB. Wait, sorry. So we're going to OB from OA. So it's that. So it's half of OB. Oh, it's a 3D thing, is it? minus OA for I. Two I, sorry, 2 minus 4 is negative 2I. And MC is the same. Also, MC is MB plus BC plus OC from OB. So we have negative 1, minus 2, minus 2. Negative 1, negative 5I. And J, negative 3J. And 2 plus 2, 8 minus 4 is 4K. So there goes our answer. CMB, angle of CMB. Angle of CMB. How you suppose should we do that? Well, I mean, we're able to find MB and CB. So if we redraw this, I'm gonna find this. Finding an angle out of two known values, two known lengths. Are we able to execute that? Do you think we're able to execute that? So using the cosine angle, let me check my MF19. No, so unfortunately we do not have the formula from MF19. So yep, looks about it. But I don't think we have enough value. Oh, but we do have enough value. So we just have to find MB that's equal to 1 squared. Insert that up. We will have 1 plus 25 plus 4. Insert off. That is 30. So like let's redraw our C M B. Insert 30. And then BC is just shoot. We're gonna have to find BC. So BC is -2 minus 2 is -4 squared. 6 minus, oops, almost got caught in that trap. Minus 8, okay, 6. 6 for 10, 10 squared. Insert that up. So I have 16 plus 64 plus 100. Insert it up is 635. So 635. And then finally, our MC. It's -5 squared plus -3 squared plus 4 squared. So that's 25 plus 9 plus 16. So that is 532. So 532. This is too tedious. I don't think this is the most efficient method we could have done. But let's just proceed. So using the formula c squared equals to a squared plus b squared minus 2ab cos c, we will have angle is equals to c squared, a squared plus b squared minus c squared over 2ab, and then the cos inverse of that. So we're gonna have angle is equals to inverse cosine of a squared. So we'll just label c as, this is c, and anything else is just however you want to put it. So this squared plus this squared minus this squared divided by 2 this and this. So putting in our calculator, we have a negative value, which is alarming. But that means that it most probably means that CMB is, it might not be acute. Oh, but this produces an error, you know. So I don't think we'll be able to solve that. Okay, let's just move on. No, you know what? We're out of time. We ran out of time. So yep, we're done now. We're done. So next, we're gonna have to we're gonna start doing our solution. Um, or not corrections, marking. So let's go ahead and open up our red pen. This for this part, there's no problem. Um, we got it all right. Let's try to bit smaller. This is all correct. Use the correct law for the logarithm. We apply the logarithm law, and then we make this and solve for x. So we got it all correct. Let's move on to this question. All right, so first question, right? Let's take a look at the. I'm going to open up the marking scheme, which is the fourth, the third question. So the first thing we should have done. So it appears I was quite stupid in doing all this very not important stuff. So what we could have done was, since this is 3, 2, so my brain was probably not activated enough. So this is, it's just a triangle, with radius 2 and uh, adjacent length of 1. So then we'll have to find this value, x. Let's call it x. So it's quite literally just um, 2 squared minus 1 squared is equals to 3 sub 3. And then it's 1 minus sub 3 I plus 2. Or in the form. So don't forget to take a look at the diagram, Okay, find the greatest value of argument z for point in the shaded region. So argument z, the greatest value obviously should be the tangent to the circle. We'll get this. So a tangent to the circle in which tangent to the circle so it's going to be what? So we're going to have to draw a right angle triangle. So, yep. It's this one. So it should have been. So we're gonna have to start with this. And it's what's the length? It's 1 squared plus 3 squared. Sort of that. It's just sort of 10. So we get cert 10. And then cert 10 squared minus 2 squared. And instead of that, 10 minus 4, 6, 36. Have 36. Wait, no, we didn't even need to do that, no? So we could have found the angle by tangent of the angle above here, alpha and beta. So alpha would have been tangent of 2, 2/secant, and beta would have been tangent of inverse tangent of 1/3. And then argument z is just this plus this should be around 57.7 degrees. So that's quite stupid of me for not knowing that. So moving on to question 4. We begin with integration by parts. Um, so we would have got the x squared. Okay, I'm not understanding this. Why is it this way? Um, we're gonna go ahead and wait. I'm trying to understand the marking scheme, so please allow me to take some time. Yep, so this is where I got it, where I got it reversed. Now we're gonna solve it, right? So right now we have, um, let's split it apart, and we want to, since this is 10, -1x, this is the integration of 1 over x squared plus a squared. No, it's something like that. Um, so which means we want to differentiate the inverse of tan. So that means inverse of tan should be the u, and then u prime should be something we find, and then v prime should be our x, and then v should be this. And so u prime, right? So let's take a look. We have tan inverse x is equals to 1 over 1 tan inverse x over 1, which means that differentiating this, we will have 1 over x squared plus 1 squared, or 1 x squared plus 1. Right. So that's our u prime, 1 over x squared plus 1. Now, uv prime, we will have uv minus vu prime. So then we'll have uv is x squared over 2 inverse of tangent, then minus differentiation of vu prime that should be x squared over, so here's our 1 over 2. Let's clean that up. Yep. So and what comes next? So this right here, so we're gonna split this first. We have x squared plus 1 equals to x squared plus 1 minus 1, x squared plus 1 equals to 1 minus 1 over x squared plus 1. So we'll have and then if we integrate that, you'll obtain the inverse of tangent. Yep, so integrating that, I have x. And this looks familiar. It looks quite like this one, which is minus tangent, inverse of tangent x. And then set our limits from 0 to 1. So we have this minus 0 squared of 2 inverse of tangent 0 half of 0 minus inverse of 0 So inverse of 0 is equals 0, right? Does it? Is it? Yep, so it's 0. So this one is 0, 0, 0. Then we'll finally obtain half of inverse 1 minus plus 1, it's minus 1 plus, and so putting in our calculator, we have half of pi over 4 plus 1 plus pi over 4. And finally, we have pi over 4, 1 over 2. Yep, I lost 6 marks on that. And this part is correct. This part is correct, correct, correct. Alright, so for this question, wait, I forgot to mark these. I mean, we got the final answer, so it should be correct. Negative 30 and 72. Correct. You know, I'm worried because this question didn't have the binomial expansion questions. So, not binomial. Is it binomial? It's the expansions. So I'll have to find another paper that does contain that kind of question. But I'll do that in tomorrow morning. So now we have question 5b. Show by calculation. No, it's 6b. So we got this one correct, and then the sketching correct. It's 2 marks. Right. So for B, firstly you have to calculate the values of a relevant expression or pair of expressions at x is equals to 0.4 and x is equals to 0.6. What does that mean? So for this question, right, we have to plug in um x is equals to 0.4 into the y is equals to cot 2x and y is equals to 2 sine 2x minus 1. Let's try that. So we have 0.9712 then we have so when we put in these values, right, we have two values of y for for x is equals to 0.4. Could see that this is greater than this, and it goes the other way around when x is equals to 0.6, which means there's a if you try to if you try to draw a line, it'll look like this. There's a crossing of path, right? Like for the for 0.4 and 0.6, y1 is greater than y2, and then it goes the other way. It goes the other way around, in which case y2 is equals to greater than y1 when the x is equals to 0.6. So that way, yeah, that earns us our first mark. Just make sure to work in radians. Then we want to justify the given statement. How should we do that? How should we do that? Let's justify. It says here f 0.4 times f 0.6 is less than 0. Oh, so I think what we can do is just rearrange this into tan 2x to sine 2x minus 1, and then minus 1 is equals to x. And then we say that f 0.4 times f 0.6 is a number that is negative, hence change there's a change in sign indicating a change in indicates that it passes through the root. Yeah. So let's move on. We got this one correct. So we got this one correct. Correct. And then this one we got correct. For then for this one we got that one correct. And for this one we got it correct. Oh, so let's go to question 8. So what should have happened is that we should have put 8 outside and then split them apart. Right. Then we would have gotten this. We want it in exact value, right? So we'll have yep, that was literally it. But I did get about 1. Is it? We were able to go to get just 1 out of 5. Proceeding to question 9. Yes, we did. And we got this one correct also. But this one, okay, so yep, this one is correct. But this one we messed up. So apparently this is a what do you call it? It's a differential equation. Is it? Yep, it's a differential equation. So let me analyze the shape here. Let's do my attempt. Let's reattempt. So we should have had dh over dt equals to 500 minus h squared over 250. And it's supposed to be 1 over 500. Would have gotten a ln of this in a negative 2h. So I'm using a wrong. I'm supposed to be using the one in MF19, so it's the a squared minus h squared. So it would have been 2 1 over 2 so 2 so 500 times just ln of a plus x, a minus x. Equals to 1 over 2. Yep. This one is plus c. So when time is equals to 0, h is equals to 20. So c no, time is equals to 0, h is equals to 0. So we would have obtained ln 1 is 0. So c, we've gotten 0 in this. Is that correct? And then we want to find the time when h is equals to 20. So time. And then it's just moving all of that. And then we obtain t is equals to 16.1. Yep, that's about it. That's 5 marks lost. And for this part, we did get it correct. But for this part, we weren't able to finish in time. So the first step was we should have applied the dot product. So 30 and 50. 50 is what? 25 times 2. So MCMB. Then it's MB is what? Negative 1, 5, 2. No, I should try to remember what dot product is. The product of its what do you call it? Its magnitude. That's the denominator. And is the length, is it? Is the length? But the length is the magnitude. Product of the magnitude. Oh, is this I plus I, j plus j, k plus k. So it's negative 1 minus 5. 5. Oh, it's the product of the I, the j's, and the k's. So negative 1 times negative 5. Wait, let me put it here. And plus 5, negative 3, and plus 2, 4. And then it's cert 30, cert 50. Then we obtain cert 15 over negative 75. And that is, yep. Dot product. And then we have to inverse of this. It's negative. Why is it negative? Try to ask this. Why is it negative? Because it's negative, obviously, when we calculate it. Anyways, for the final question, find the exact area of the triangle A, B, and C. So apparently I could have got this wrong and question right if it weren't because of this working. But never mind. We'll just learn from our mistakes, right? That was BC, you know? Also, it should have been negative 2, you know? This part should have been 2, just 2. So that was my mistake. Let's continue. It's the last part. Let's go. We are almost done. So for this part, right, we're working with triangle MC. Calculate the exact value of CMB. So since this is a midpoint, so we just have to calculate this, and then we times 2 to get this. So CMB we already have. Wait, yeah. Right, so first of all, we just find inverse of cos. This, and we sine CMB is equals to so it's just area is equals to and then we times 2. Now what we want to be careful with is that make sure not to round off your values when you're asked to find the exact value. So yeah, we're pretty much done. Now we're gonna total up our marks. So it's starting from below. It's a 2 plus 4 plus 4 plus 5 plus 1 plus 3 plus 4 plus 4 3 2 5 2 4 2 1. So we got a 46 out of 0.75. So that's that. But according to the great thresholds, 25 looking at the great thresholds, component 32, we needed a 45 for A. Yep. So I think we're done now. I'm just gonna go ahead and save. Thanks for watching. If you're from the future, hello. Thanks for joining thanks for taking a look at my video, and goodbye. Thanks.